Hello everyone, Mr. Lee here. In this video, we're going to go over more free response type of questions, but this time we're going to go over the type of question called the QQT. Now the QQT, the Q and the T, they stand for something. So the first Q stands for quantitative, which is what we call a algebraic manipulation of variables. So think about like things that you would do with numbers, either with equations or trying to determine like the slope of a line or just straight up calculations, but with numbers. Qualitative, which is the second Q, is the reasoning. It's the something using words in paragraph form. Okay, so what you're doing is this is the more conceptual one. You are doing physics without numbers and just more with your words and your understanding of the natural laws of our universe. Okay, and the T stands for translation or translative, and that allows you to go from back and forth from the quantitative to the qualitative. Okay. So with that being said, let's take a look at how we can do our best on these QQT types of FRQs. So these are going to be the longer free response type of questions, and they are worth more points. They are worth a total of 12 points compared to the other ones, which are worth like maybe 7 points. So there are more opportunities for you to do well on the QQT, thinking positive here. The hardest part about the QQT is that you have to be able to explain your math using words, and you have to be able to do math while just looking at words. Like it goes back and forth. The different information, it can be presented as equations, and also this new thing called false equations. And I'll show you an example in a little bit. But false equations are equations that you cannot find on the equation sheet. In fact, these equations don't really exist in the real world. These equations are simply there to describe a situation, and it allows for you to utilize your knowledge about math and how numbers work to really see if these false equations are even remotely correct. There's this thing called a narrative description. And narrative description is like a student having a prediction. Okay, there's graphs and there's diagrams, and of course there is data table. So information can be presented in many different ways, and that's what makes these QQTs a little bit more difficult. You have to be very well rounded with your knowledge and your ability to communicate. So it's really important for you to understand this final point, that if you have a strong conceptual understanding of material, rather than the ability to just, find the correct equation and to solve for a missing variable, you'll probably do well with these QQT questions. And so hopefully, with you and your peers, you were able to discuss different kinds of problems and have the ability to really go through and discuss the ideas that go behind physics. Okay, so these are the tips, and you'll notice that these are the same tips from before if you watched my other video. And the most important part, of course, is to please make sure you are answering all parts of the question. I cannot emphasize this enough. You cannot get points if you don't answer the question, right? You have to be very explicit. If they ask for something, you have to answer it. If they ask for something and you write all this great stuff down, but it doesn't answer the question, unfortunately, you'll get no points. And we'll go over how to get the most amount of points while taking a look at the different ways that the QQTs can be represented. Let's begin. All right, so here's the frequently asked type of questions. Okay, we have the student work. So what this is a hypothetical student, like a peer that you might come across in any kind of physics class. So they'll make a statement, right? They'll say, I believe that when objects are dropped from the sky, the heavier objects will fall faster, right? So those kinds of statements, like things you might hear in the classroom. And it's up to you to figure out what's correct and what's not. And we went over the equations. So these are the type of equations that a student might come up with based on a lab set of data. And it's up to you to see which parts of those equations are true and which parts of those equations are false. Okay. All right. And the other type is the flip side, where instead of having a hypothetical student come up with these statements or these equations or different kinds of work, it's up to you to come up with the correct statement. It's up to you to make up these kinds of equations, and it's up to you to have the correct information down. All right, so I'm going to go over the 3 types of questions that you will see and how to do best on those 3 types. So the first type is the evaluating graphs. Now, just so you know that these are the example students, the hypothetical students that come up with these types of things. But if you just flip the idea of instead of having a hypothetical student come up with these type of examples, if it's you that were to come up with these types of examples, this is how you can do well as well. Okay, so if you were given a hypothetical example graph, okay, there are 3 things that you should immediately look at first. And the 4th one, not as much, but it's also very important. So the first one is called the slope, right? You got to take a look at the slope. Look at the general trend of the slope. Is it going up? Is it going down? Is it flat? Does this slope make sense in the context of the problem? Should there be a increasing slope? Should there be a decreasing slope? Should there be no slope based on the information that is given? Okay, so you have to see that and you have to assess, does this make sense? The y-intercept. So this is something that we usually don't really come across because a lot of the times our y-intercept starts at 0. But sometimes they love to throw these curveballs at you and they're like, you know what? We're not going to start the graph at 0. And we're going to see if you can figure out if that is the correct way to draw this graph. Now, just as I red alert, okay, a lot of students, when they see a graph not start at 0, they immediately think that that is what's incorrect because they're not used to it. But you gotta be smarter than that. You can't be tricked. Okay, you gotta take a look at the scenario. You gotta take a look at the information and be like, does it make sense that this y-axis values start at this point? And of course, the last one is the type of curve, and this is all about relationships. Okay, so the most common type of curves that you'll see is either a linear curve or polynomial. So linear is just straight, directly proportional, and a polynomial is like a x squared kind of situation where it goes whoop like that. Okay, and does that kind of curve make sense for this type of graph? And once again, it all depends on the scenario that is given. Now, my best tip for trying to figure out if the type of curve makes sense is to actually find a real life equation from your equation sheet and look in that equation sheet. Okay, if you don't see any variables that are squared, there's a high chance that the graph shouldn't show a curved line. Makes sense, right? All right. Okay, evaluating equations. Now, this one's a little bit longer, but a lot of the information there is something that we've been practicing, so I won't go into too much detail with that. So oftentimes you'll be given made-up equations with like real variables like m for mass, t for time, v for velocity, right? And these will be made-up equations. They can't exist in real life. And so if they can't exist in real life, you might be wondering, well, what are they really asking? So basically what they're asking is, can you look at any equation that they throw at you, real or not, and assess, does this variable in comparison to another variable make sense in the context of the problem? And that all comes from the relationships, right? And so if you have 2 variables side by side on opposite sides of the equal sign, it's directly proportional, and it goes from there, right? If the variables are on opposite sides of the equal sign, but one is squared, that is a directly square proportional, and the list goes on. So make sure you are familiar with these types of relationships because you will come across them in these type of problems. Now here, this is all just on a one-to-one basis, but there's a high chance that like it could be y equals x, z, a plus d all over q squared, right? So they'll give you a lot of variables at once, and so it's just up to you to be able to take a look at each one of those variables individually and see what the relationship is between those variables. Okay, and my tip is to always have the variables that you are comparing on either ends of the equal sign, so that you can see what the proportionalities are. All right. And the last one is called evaluating student statements. So this is the things to look out for. And just so you know, this is usually the criteria for free response questions for short paragraphs where you have to come up with a statement. And this is the rubric that the graders and the readers are given to see if you get any points at all. Okay, we're told to look out for any incorrect kind of physics, right? So if you're talking and you're talking and you're talking and you break a fundamental law, such as the conservation of energy or conservation of momentum within your statement, we can't give you that point. You just broke a fundamental law of the universe. a incorrect usage of proportionality, and that goes from the previous slide where we had directly proportional, inversely proportional. So for example, what I mean by this is if there is a clear inversely proportional relationship, and within your statement you say as variable A increases, B also increases. So that's a directly proportional. When within the equation it shows as an inverse. So you should say as A increases, B decreases. Okay, or a combination of two. Okay, oftentimes in these statements, it's kind of hard actually, because what they do is they get statements that students would normally say in any kind of classroom environment, and they would ask you to find what's wrong with it. And so those two are the most common things that you should look out for. Okay, all right, and I can't hone this in enough. You have to be able to look at the equation sheet and use that equation as evidence for your proof. Okay, those equations are there for a reason. Those equations are what governs our universe, right? Okay, so I have a little example scenario down here. It says if you double the velocity of a ball, then the kinetic energy will also double. And if you look at the kinetic energy equation, which is 1/2 mv squared is equal to the kinetic energy, you'll notice that kinetic energy and velocity, they have a directly square proportionality. And so if you double the velocity, the kinetic energy will actually quadruple. Okay, so just stuff like that, very slight things that are kind of hard to really take a look at. All right, so what we're going to do now is I am going to show you the official course description for AP Physics 1, and this is a QQT type of problem. Okay, and so what I want us to do is I want us to take a look at the equations and see, you know, is it a quantitative, is it a qualitative, and just go from there. And take a look at the answer key as well to see exactly how these are graded. So the first one, so without taking a look at the scenario, but you can, you know, if you want to look at it, it's there. We have two student statement. Okay, it says here, two students are discussing the motion of the sphere and make the following statements. Okay, so this is a qualitative, because there's no numbers involved, there's no calculations that you need to do. You just have to see if their physics is correct. And what they give you is student 1 statement, and we have student 2 statement. And without actually solving it, let's take a look at what the problem is asking. It says, what is one aspect of student's reasoning that is incorrect? So all you have to do is answer the problem. Read student 1 statement and see what part of student 1 statement breaks the laws of physics. Okay, and same with A2. It says, what is one aspect of student 2's reasoning that is incorrect? Just read that and see what is incorrect. Okay, so if you do that, you should get your points. And let's see if that holds true. So this is the key. We can see that part A is worth 2 points, and you get those 2 points if you talk about student 1 that is incorrect. It says 1 point for a claim, explicit or implied, that the sphere can have a centripetal force without any individual force pointing toward the center of its circular path. Okay, so that's what was wrong with student 1. So if you say anything like that, you get a point. Okay, very clear cut. Okay, B, it says derive an equation for the magnitude of the net force exerted on the sphere. Express your answer in terms of m, theta, and physical constants as appropriate. So what this is asking for you to do is to set up the equation. And here's the thing. If they give you the variables, you must use those variables. And whenever they're talking about physical constants, so that's anything that is on the equation sheet that is declared as a constant. So that's like G for acceleration due to gravity, or K for spring constant, so things like that. Right? And part 2 says describe one aspect or step in your derivation of part B that can be correctly linked to your answer to either part A1 or A2. Now this is what's cool. This is the T. So this is asking you to take something that is more quantitative, right? Something where you have to really calculate and you have to figure out things. Okay, because if you come up with an equation, you can come up with a numerical part, and this is asking you to combine your knowledge of the qualitative part, which is what we have above in part A, to the quantitative part, which is what is in part B. So what B2 is basically saying is, can you explain what you just did, but using words instead of an equation? Okay, so if we take a look at the answer key, well, this one's a little bit longer. It's worth a total of 4 points, right? And so you'll notice here in the correct answers, they use all the variables that they want you to use. So instead of using a lowercase m, they ask you to use a capital M. and it's there, and G is one of those constants, right? And all they did is they created a net force equation based on this scenario. And B2 is asking for you to connect your equation that you came up with your statements for A1. All right. Now, if we continue down here, here's the graphical portion. All right, so we're given a graph here. It says on the graph above, draw a best fit line for the data, then use the line to calculate a numerical value for the gravitational acceleration G. Now, here's something that's cool. So a lot of students, easy, right? Line of best fit, boom, draw a straight line, or maybe even a curved line sometimes, be careful. That really, shows the trend of these points, and is asking you to find the gravitational acceleration G. All right, now here's the tip. Now, if you remember from the slideshow, one of the things that you should always look at are the axes. So we have period of a pendulum, t squared, and we have the length of the string, L, right there. And so what you should be able to do is you should be able to find the equation for the period of a pendulum equation, okay, and see how the gravitational acceleration G fits into that equation, right? Is it the slope? Is it area under the curve? Is it a slope divided by something, right? So that's a skill that you can do. And here we have a secondary graph, and it says graph shows above the angle theta from the vertical as a function of time for the pendulum. On the axis below, sketch a graph of the gravitational potential energy of the sphere Earth system for the same time interval. Take 0 potential energy to be when the potential energy has its minimum value. So here you are drawing your graphs, okay? And your graphs have to, of course, make sense. So this is going from a qualitative to a quantitative and vice versa. All right, and the last part here, I just want to showcase this because we started off this QQT with a statement from 2 different students, and we are actually ending this QQT with a statement of your own. Okay, and so this is how they are able to connect the qualitative to the quantitative, and it kind of like mirrors what they want you to do, right? So in one graph, they asked you to draw the line of best fit without any data. And another graph, they give you the data and they ask you to figure things out, okay? So it's a very well-rounded question to really assess, are you a student that can do more than just find the correct equation and plug in the numbers? I'll have a link to this course example and exam description in the description, so you can check out this QQT. If you want to know where this starts on page, let's see, 230. So these are just my quick little tips. We'll get a lot of practice in us addressing these type of questions in class. But it's good to know what these questions are asking for. I'll see you next time. Bye-bye.